Welcome to Laws of Indices Level 6. Pause the video now, try the 4 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're told that 27 to the power of p plus 5 is equal to 3 over 81 root 3, and we need to find the value of p. Now, in order to use our laws of indices here, we need to write each value to a power using the same base. And we can see here that 3, 27 and 81 can all be written as powers of 3. So 27 to the power of p plus 5 is equal to 3 over 81 root 3 can be rewritten as 3 to the power of 3, because 27 is 3 times 3 times 3, to the power of p plus 5 is equal to 3 over 3 to the power of 4, because 81 is 3 times 3 times 3 times 3, multiplied by the square root of 3. Now, looking at the left-hand side, we're raising a power to another power. So we can use this law, which tells us that we need to multiply the powers together to simplify. So multiplying together 3 and p plus 5, we have 3 to the power of 3, and then p plus 5 in brackets, is equal to 3 over 3 to the power of 4 multiplied by, and rewriting the square root of 3 as the square root of 3 to the power of 1, we can see that we have a power and a root on our 3. And so we can use this law to rewrite it. And the law tells us that we can rewrite the square root of 3 to the power of 1 as 3 to the power of 1 over 2, or a half. Continuing with the left-hand side of the equation, we can simplify by expanding our bracket. So we have 3 to the power of 3 times p, which is 3p, plus 3 times 5, which is 15, and that's equal to 3 over, and in our denominator on the right-hand side, we're multiplying indices together. So we can use this law, which tells us that 3 to the power of 4 multiplied by 3 to the power of a half becomes 3 to the power of 4 plus a half. Now, staying with the denominator on the right hand side, we can simplify this by adding together 4 and a half. So this becomes 3 over 3 to the power of 9 over 2. And the left hand side of the equation is still 3 to the power of 3p plus 15. Now, the fraction on the right hand side of the equation tells us that we're dividing indices. And if we rewrite the numerator as 3 to the power of 1, we can use this law, which tells us that 3 to the power of 1 divided by 3 to the power of 9 over 2 is the same as 3 to the power of 1 minus 9 over 2. And the left hand side of the equation is still 3 to the power of 3p plus 15. Now, 1 minus 9 over 2 is equal to minus 7 over 2. So the right hand side becomes 3 to the power of minus 7 over 2. And now we can see that both sides of our equation are written using the same base, which is 3. So we can now say that the powers on each side are equal to each other. And so 3p plus 15 must be equal to minus 7 over 2. To solve this equation, we can start by taking away 15 from both sides. And this gives us 3p is equal to minus 37 over 2. And finally, by dividing both sides by 3, we get to our final answer, which is that p is equal to minus 37 over 6. In problem 2, we're told that a is equal to 4 to the power of x, and we need to express 2 to the power of 4x squared over the 4th root of 8 to the power of 8x in terms of a. Now, starting with the fraction itself, we need to simplify this in the hope that we can write it in terms of a. Now, starting with the numerator of this fraction, we can see that we're raising a power to another power. So we can use this law, which tells us that to simplify, we multiply the powers together. So in our numerator, 2 to the power of 4x raised to the power of 2 becomes 2 to the power of 4x multiplied by 2, which is 8x. Now in our denominator, we have 8 to the power of 8x and the 4th root of that. Now, since we have a power and a root on our 8, we can use this law, which tells us that the denominator can be rewritten using a fractional power, and that the numerator of the fraction is 8x and the denominator is 4. So our denominator becomes 8 to the power of 8x over 4. Tidying up our denominator, we can divide 8x by 4 to give us 2x. So our fraction becomes 2 to the power of 8x over 8 to the power of 2x. Now, in order to be able to use our laws of indices here, we need the 2 to the power of 8x and the 8 to the power of 2x to be written using the same base. And we notice here that 8 can be written as 2 to the power of 3. So our denominator becomes 2 to the power of 3, because 2 times 2 times 2 is 8, raised to the power of 2x. And our numerator remains as 2 to the power of 8x. Now, staying with the denominator and using our power law, we can see that we can simplify this by multiplying together 3 and 2x. So our fraction becomes 2 to the power of 8x over 2 to the power of 3 times 2x, which is 6x. Now, this fraction means that we're dividing the top and the bottom. So to divide indices, we use this law, which tells us that 2 to the power of 8x divided by 2 to the power of 6x is exactly the same as 2 to the power of 8x minus 6x. And since 8x minus 6x is 2x, this becomes 2 to the power of 2x. Now that we've simplified the fraction, in order to write it in terms of a, we need our base, which currently is 2, to be 4. And so once again, we can use our power law to rewrite 2 to the power of 2x as 2 to the power of 2 raised to the power of x. And we're doing this because we know that 2 to the power of 2 is 4. So this becomes 4 to the power of x. And since a is equal to 4 to the power of x, our final answer is that our expression is equal to a. In problem 3, we're told that the cube root of the square root of a to the power of 5 over 2a squared raised to the power of 3 is equal to k times a to the power of h. And we need to find the values of k and h. Now, looking at the right hand side, we have a to the power of h. So what we want to do with the expression on the left hand side is write it as a power of a. So we need to start by removing the roots on the numerator and the brackets in our denominator, and we can hopefully then use the laws of indices to simplify this into the form that we want. So starting with the numerator and starting with the square root of a to the power of 5, we can rewrite this using this law, which tells us that a will have a fractional power on it, and that the numerator of this fraction will be 5 and the denominator is 2. So the square root of a to the power of 5 is equivalent to a to the power of 5 over 2. We now need to take the cube root of this. So the cube root of the square root of a to the power of 5 becomes the cube root of a to the power of 5 over 2. And we can use our law again to rewrite this as a to the power of 5 over 2 in our numerator over 3 in our denominator. And since 5 over 2 divided by 3 is 5 over 6, this becomes a to the power of 5 over 6. And that's our numerator. Looking at our denominator, we have 2a squared raised to the power of 3. Rewriting the 2 as 2 to the power of 1 allows us to see that we're raising powers to powers here. So we can use this law, which tells us that to simplify, we need to multiply the powers together. So starting with 1 times 3, this becomes 2 to the power of 3. Next, 2 times 3. So we have a to the power of 2 times 3, which is 6. And simplifying further, 2 cubed is 2 times 2 times 2, which is 8. So our denominator becomes 8a to the power of 6. Putting this all together means our original fraction, which was the cube root of the square root of a to the power of 5 over 2a squared raised to the power of 3 is equal to a to the power of 5 over 6 over 8a to the power of 6. Now this fraction means that we're dividing the numerator by the denominator, and since we're dividing indices we can use this law, which tells us that we need to subtract the powers. So starting with 1 divided by 8, this gives us 1/8, and a to the power of 5 over 6 divided by a to the power of 6 becomes a to the power of 5 over 6 minus 6, using our law. In order to subtract 6 from 5 over 6, we're going to write each of these with a common denominator. So we have 1/8 a to the power of 5 over 6 minus 36 over 6. Subtracting these numbers gives us 1/8 a to the power of minus 31 over 6. And we know from the question that this is equal to k a to the power of h. So comparing the left and the right hand side here, we can see that k is equal to 1/8 and that h is equal to minus 31 over 6. And this is our final answer for problem 3. In problem 4, we're simplifying 64x to the power of 6, y to the power of 8, all raised to the power of a half, multiplied by the cube root of 8x to the power of 6, all raised to the power of 3 over 2. Now starting inside the bracket and looking at our first term, we have 64x to the power of 6, y to the power of 8 to the power of a half. And we can see here that we're raising powers to powers. So we're going to use this law, which tells us that we can simplify this by multiplying the powers together. And it's really important to realise that 64 has a power of 1 on it. So starting with that power of 1, 1 times a half is a half. So we have 64 to the power of a half. 6 multiplied by a half is 3. So we have x to the power of 3. And 8 multiplied by a half is 4. So we have y to the power of 4. Now 64 has a fractional power on it. So we can simplify this by using this law, which tells us that the numerator of the fraction is the power on 64 and the denominator is the root. So 64 to the power of a half becomes the square root of 64 to the power of 1. Now since the square root of 64 is 8, because 8 times 8 is 64, and 8 to the power of 1 is 8, this just becomes 8x cubed y to the power of 4. Moving on to the next part of that bracket, which is the cube root of 8x to the power of 6, we can once again see that we have a root. And on this 8x to the power of 6, we also have a power of 1. And since we have a power and a root, we can use our fractional power law to rewrite this again. And so the cube root of 8x to the power of 6 to the power of 1 becomes 8x to the power of 6 to the power of 1 over 3. As we saw earlier, we're now raising powers to powers, so we can use our power law. And again, putting a power of 1 on our 8, we're going to start by multiplying together 1 and a third, which gives us a third. So we have 8 to the power of a third, and 6 multiplied by a third is 2. So we have x to the power of 2. 8 to the power of a third can again be rewritten using our fractional power law as 8 to the power of 1 cube rooted. And we have our x squared afterwards. Now the cube root of 8 is 2, because 2 times 2 times 2 is 8, and 2 to the power of 1 is still 2, so this becomes 2x to the power of 2, or 2x squared. Putting these two together, our original bracket now becomes 8x to the power of 3, y to the power of 4, multiplied by 2x squared, raised to the power of 3 over 2. Now inside this bracket, we're multiplying indices together, so we can use this law, which tells us that we need to add the powers. So starting with 8 times 2, we have 16. X to the power of 3 multiplied by x to the power of 2 becomes x to the power of 3 plus 2. And we also have a y to the power of 4. And this is all raised to the power of 3 over 2. Now, since 3 plus 2 is 5, our bracket becomes 16x to the power of 5, y to the power of 4, raised to the power of 3 over 2. Again, we're raising powers to powers here. So using our power law and putting a power of 1 on 16, we can start by multiplying together 1 and 3 over 2. And this gives us 16 to the power of 3 over 2. 5 multiplied by 3 over 2, which gives us x to the power of 15 over 2. And finally 4 multiplied by 3 over 2, which gives us y to the power of 12 over 2. Again, 16 to the power of 3 over 2 can be rewritten using our fractional power law as 16 to the power of 3 square rooted. We then have x to the power of 15 over 2 and y to the power of 12 over 2, and 12 over 2, or 12 divided by 2, is just 6. Now looking at the square root of 16, this is 4 because 4 times 4 is 16. So we have 4, still with a power of 3 on it, x to the power of 15 over 2, y to the power of 6, and finally 4 cubed, or 4 to the power of 3, is 4 times 4 times 4, which is 64. So our final answer for problem 4 is 64, x to the power of 15 over 2, y to the power of 6.